Hydrogen is viewed as a promising alternative to fossil fuel, but the methods used to make it either generate too much carbon dioxide or are too expensive. Now, Rice University researchers have found a way to harvest hydrogen from plastic waste using a low emissions method that could more than pay for itself. In this work, we converted waste plastics, including mixed waste plastics that don't have to be sorted by type or washed, into high yield hydrogen gas and high value graphene, said Kevin Wiss, lead author of a U.S. National Science Foundation Graduate Research Fellowship Program supported study published in Advanced Materials. If the produced graphene is sold at only 5% of current market value, a 95% off sale, clean hydrogen could be produced for free. By comparison, green hydrogen, produced using renewable energy sources to split water into its two component elements, costs roughly $5 for just over 2 pounds. Though cheaper, most of the nearly 100 million tons of hydrogen used globally in 2022 was derived from fossil fuels, its production generating roughly 12 tons of carbon dioxide per ton of hydrogen. The main form of hydrogen used today is gray hydrogen, which is produced through steam methane reforming, a method that generates a lot of carbon dioxide, said James Torr, a materials scientist. Demand for hydrogen will likely skyrocket over the next few decades, so we can't keep making it the same way we have up until now if we're serious about reaching net zero emissions by 2050. The researchers exposed plastic waste samples to rapid flash Joule heating for about 4 seconds, bringing their temperature up to 3,100 degrees Kelvin. The process vaporizes the hydrogen present in plastics, leaving behind graphene, an extremely light, durable material made up of a single layer of carbon atoms. When we first discovered flash Joule heating and applied it to upcycle waste plastic into graphene, we observed a lot of volatile gases being produced and shooting out of the reactor, Wiss said. We wondered what they were, suspecting a mix of small hydrocarbons and hydrogen, but lacked the instrumentation to study their exact composition. We know that polyethylene, for example, is made of 86% carbon and 14% hydrogen, and we demonstrated that we are able to recover up to 68% of that atomic hydrogen as gas with a 94% purity, Wiss said.